Hello, Professor. I'm Manideep Kavuri, industrial engineering student. I'm here to present our project, redesign of coconut dehusker. Uh, here we developed a model which is used to dehusk the coconuts. The coconuts are the major crops in some areas. So the critical step in processing the coconut is the dehusking. So it was done manually all the days, but there are many missionaries come, and we have developed a model which we have chosen, and we have developed the rollers along with that, which is used to take the dehusk in very less amount of time. And the objective of our project is to redesign the coconut dehusker with simple design changes in the frame and add some rollers and to decrease overall material used in the manufacturing, reduce the number of parts required for modeling, and to develop the CNC of a desired part in the whole in the whole system. And the introduction to our project is the dehusker machine is usually a mechanical control dehusking device known as spiked rollers. This dehusking machine peels the coconut husk. To obtain the dehusked coconut, a gear, belt, and sprocket transmission system must be used in the delivery of the power from the motor to the cylindrical rollers with spikes, which tends the coconut to stuck in that, and with the revolving motion tends to take off the peel. The dehusk unit is made up of several cylinders, rollers that are linked to the surface type of bodies. Between the rollers of the cylinder, the coconut is placed in the middle. The roller will rip the coconut fiber from the shell as the revolve of the rollers by the motor, which is powered by that. Dehusking is more effective and less time taken process to remove the fiber of the coconut and are properly meshing. While designing the machine, the form size of the coconuts are considered. According to that, the rollers has been changed. And here are the parts of our model. The main parts are the frame, the rollers with spikes, the gears, the pulley, the motor coupling, the pulley and the pulley belt. These are the essential components in which we use to redesign the coconut dehusking machine, and the rest of the slides will explain by my teammate Aditya.
Hello, Professor. My name is Aditya, and here you can see the exploded view of the new model, which consists of frame, two rollers with the spikes, and a small motor, which is accompanied by a gear, which is connected to the other gear, which has a pulley and a belt. And coming to the bill of materials of this project or the model, and it has one frame, which is steel, and two spike rollers of the rods, which is again the steel, two gear systems, one pulley, a motor and a belt. And here if you see the old model, which is very heavy and bulky, which consists of a large belt, two pulleys, and a motor, a frame which is very compact, which is not compact actually, and we have a mechanism where we can slide all the coconuts into the machine, which gives the output. This is somewhat kind of complex, so we have planned and designed somewhat new, which has a simple frame, motor alignment, and the pulley alignment. And in addition to that, we have added the spikes, which makes the design very simple to the rollers. And with the concept of DFM, this concept of DFM is like design for manufacturability. also sometimes known as the design for manufacturing. DFM is the general engineering art of designing products in such a way that they are easy to manufacture. The basic idea exists in almost all engineering disciplines, but of course the detail differs widely depending on the manufacturing technology. The design practice not only focuses on the design aspect of part, but also on the productability. In simple language, it means relative ease to manufacture a product, part or assembly. The design stage is very important in product design. Most of the product lifecycle costs are committed at the design stage. If this process is not followed diligently, the product may fail at manufacturing stage. And in this project, we have the areas of improvement. In the original product, the frame is a little bit complex to do something for the DFM. Therefore, we consider how can reduce the parts pattern that needs to manufacture the complex part without compromising the features of the product. We also considered in our modified or proposed product how we can manufacture different parts easily. We basically redesigned three distinguished criteria for the DFM. The first one is the frame, the next one is the rollers, and the third one is the belt and the motor. And in this frame, the design is very simple, which is U-shaped, which has two square slots and four screw slots. And we can insert the two rollers into the two slots, which has four holes. And to those rollers, we can add the pulley, which comprises of a belt. And coming to the rollers, we added some spikes to the rollers, so the material is reduced comparatively. That's how we made some modifications to our rollers with spikes, which was done by giving the concentration for DFM. Belt and the rotor. The width of the belt is gradually reduced with respect to the motor size. In the old design, there are a lot of features which we found while drawing. The parts of the new design are not simple as they look like. When we drew it in Fusion 360, we found various number of complex parts in the original product. In the modified one, we reduced the complex features, which makes the manufacturing simple. This is the modified frame, belt, and we can see there are four slots to keep the two rollers with spikes and um, the pulley with the belt. Coming to the DFA concept, design for assembly concept, this is a process by which products are designed with ease of assembly. If a product contains fewer parts, it will take less time to assemble, thereby reducing the assembly cost. In addition, if the parts are provided with features which makes it easier to move, orient, and assemble them. This will also reduce the assembly time and assembly cost. And into the project, there are general guidelines in the DFA. The first one is the design for ease of fabrication. The next one is the design for parts, orientation, and handling. Simplify the design and reduce the number of parts. Standardize and use common parts and materials. Eliminating leak parts. Color code parts that are different but shaped similarly. Design modular products. Design for automated production. And in this project, we have a result which is based on the criteria, original model, and the modified model. And coming to the criteria, the first one is the type of parts. In the original model, we have nine types of parts, but in the modified model, we only have 6 types of parts. The total number of parts in the original model is 15 and 9 in the modified model. And the manufacturing is complex in the original model, but easy in the modified model. The assembly is also complex in the original model, whereas it is easy in the modified. And the operational complexity is less in the modified model, whereas it is actually complex in the original model. Conclusion of this project. In the end of the project, we can conclude that modified model clearly satisfies the target of the project without violating the main purpose of the product. DFM and DFA is implemented brilliantly in the proposed design, which in some portion improved the functional design, though it was not our goal. Moreover, some more modification would have been done in future.